Hello everyone. Welcome back to Python Challenge for All. Okay, so last time we made we 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 tried to see how we can generate an RSA key pair, which is used for public key cryptography. Okay, so yes, just briefly we summarize. Pick up large primes, two primes, P and Q, calculate n and phi. Phi is Euler's totient function. And using E with phi, we calculate D, private key, okay, which is a modular inverse of E mod phi. Okay, that's now we have two tuples, En, public key, and Dn, private key. So today we're going to use these keys to see how we can make the encryption and decryption using RSA. Okay, so let's continue. Use a public key scheme to let others send you secrets. So the basic scheme is you make your public key, which you calculated last time, public. You publish it, and other people can see it, and they will use it to encrypt any message they want to send to you. And only you, who knows the secret key, can decrypt it. That's how it works. Okay, so let's go and work with it. Okay, so the first thing to do is, yes, as I said, the public key you made, NE, publish it, and private key, ND, keep it secret. Now we can use, yeah, the computation to make new messages. And so basically, encryption is done by calculating for every byte in the message, compute power, b to the power of E, modulo n, and use it. For decryption, we use for every integer in the message, encrypted message, compute V raised to the power of D, modulo n. And actually, this is what we get after decryption. Okay, let's see. Try it with our code. Okay, convert text to byte. And this is very close to what we did previously with the common key case, shared key case. So let's copy this part from the common key description, and let's see how we can reuse it. Okay, from here we copy it under here, and so this will do. So we'll let you input text, and if it's empty, exit it, and then change it to byte sequence using orgtext.encode UTF. And then next is different, okay? So instead of cipher, we use new function enc. So here we define enc function, encoding function, which takes byte data and public key. Okay, and so we unpack it. Okay, public en equals pub key. Okay? This is how we packed it. En, tuple of en. Now, encryption is very simple. As I said, it's we can make bytes and power of no, not bytes, but just sorry, just list comprehension of power byte to the it raised to eth power modulo n, and that's it for B in data. Okay, this is all. Okay, so encryption is power B raised to E modulo n for byte in data. This is what I wrote here. Okay. Now, so we use this function to, instead of cipher, enc. Okay. Input is oric text B and pub key. Okay. So we get the encrypted message using the public key. Now, the decryption part, very similar. So instead of cipher, you use another function, which is dec function, which takes encrypted list plus pref key. And as before, we unpack the pref key. Just like here, we packed as dn and return. And this time, we change it to bytes and power of, okay, we don't need this, power of, just I wrote, v d n for v in enc l in enc l. So the point is, okay, point is the encryption will make a list of integers. Okay, so let's put it this way. After encryption, it will be not the byte code, but it's a list, not enc B, but enc L. Okay, enc list. So we will just put, first we'll write the length of it. Enc L. And maybe print out the first 10 elements of it. Okay. Enc L top 10. Okay. This will print out the top 10 elements in the enc list. Okay. So taking that enc L, we decipher it using dec, enc L, and pref key. Actually, this is all. We are ready. So we now dec it, and just in case, decode it. And change it back to text. And I think this is all. Okay, let's try this to see how this works. Okay. Change it to text, encrypt it, and decrypt it. Yeah, encryption will make a list of integers, and decryption will take the list of integer using pref key, change it back to byte sequence. And we know how to convert byte sequence, either print or back to the original text. So let's see how this works. Okay, text. Today is a fine day. Okay. Oh, there's a mistake. Base 64 not defined. So maybe we will import base 64 here. Okay, do it again. pub key is not defined. Oh yeah, right. This should be not print, but pub key, pref key. Yeah, right. Gen key will return the tuple of pub key and pref key. So this should work. Let's try again. Okay, now it's successful, right? This is the original text consisting of 20 characters. Converted byte sequence is this, and it will change to sequence of 20 integers like these, blueprinting the first 10. And now using dec function, we change it back to the original, close to original, byte sequence. And if you decode it to text, it will be just like this, okay? So yeah, of course it works fine. Yeah, so now you can see how this works. And it works beautifully with the public key encryption scheme. Okay, so try yourself and see how well it works. Okay, that's all for today. Come back again next time. Bye bye.